Hey everyone, welcome back to the shop and welcome to the Rivett 8-inch Precision. I'm not having any spindle issues with this machine, at least none that I know of. It's perfectly smooth, and doesn't have any tight spots. All around, I'd say it's still in great shape after 100 plus years. The build date on this machine is 1910, so at the time of this video, that makes it about 109 years old. There's a fellow Rivett lathe owner who I've been corresponding with, and he recently had some questions about disassembly and reassembly of the headstock, particularly around the spindle. It's a good idea to disassemble and clean and inspect things periodically anyways, and it's been a while since I've had this apart, so great opportunity to kill two birds with one stone. I can disassemble this and see how everything looks after 109 years. Probably not substantially different from how it looked about a year ago, the last time I had it apart. And maybe provide some useful information to others who may have a similar model Rivett interested in taking their spindle apart. Not quite sure how to go about it. Maybe a little nervous about disassembling it and messing something up. So I'll bring you guys in a little closer and we can start tearing her apart. I'm going to start by taking off the spindle thread protector here. And this cap here is pretty much a dust shield. It's a pretty snug fit, or it should be anyways. It's there to keep particles out of this bearing surface along here. So what we have here effectively is the front thrust bearing. These are often going to be really difficult to unscrew, especially if the lathe is new to you and it hasn't been removed in a very long time. Try to resist the temptation to resort to channel locks or vice grips unless you absolutely have to. And even then try to protect the part from the jaws a little bit and be gentle, because it is a fairly thin section part here. It's easy to distort. Let's take you around to the other end of the headstock. I have a lever closer mounted here. I don't use it very often. Typically I use the threaded draw tube instead. But this collet closer is going to have to come off enough to get out of the way for us to continue. I'm just disconnecting it at the pivot point here, rather than take the entire assembly off of the headstock. This is a bit easier, I think. I'm going to take this rear cover plate off next. This is probably a good time to mention that this is a pretty early machine, an 8-inch Precision rather than a 608. So there are some differences between this and the later machines branded as 608s. I'm going to swing the banjo out of the way for the change gears. Banjo, sector, whatever you want to call it. I'm going to put the tumblers in neutral here. The tumbler mechanism and this output arrangement here could differ between some models based on what I've seen, but this is what I've got. You may find yourself needing some pretty broad-tipped flathead screwdrivers, and you might have to reshape them a bit to fit correctly. This one here is marginal, but it's okay because I never really cranked this down tight. We're going to come back out here in a moment. There's some bearing adjustment nonsense going on here that we'll talk about. Let's move out to the back gears. Nothing real complicated going on back here. There's a couple of eccentric bushings in either end of the shaft for engaging and disengaging. Those bushings are held in place on the undersides of the castings here. So underneath this lobe of the casting, there's a set screw, and on this machine it's a flathead. And over here on the lever end, same thing, on the underside, a flathead set screw. Here's one side. And the other side. You can see that without those screws in place, the back gears drop pretty far out of position. You can also see that it lets us get easier access to the set screw on the bottom of this lever here. So there's a flat on the shaft here that engages with the screw. In my case, it looked like someone made their own at some point. They were probably having issues with adjusting the back gears in and out of mesh. Right under here is a really shallow recess put in place to help remove these bushings. If they don't slide out easy, you definitely don't want to force them. You see that a little better there, the little recess put in place. You'll want to take note of the orientation when you're removing them. These dimples in the bottoms of the bushings here engage with those set screws on the underside. So they really only go one way, but just make sure you don't get them 180 out and end up putting the set screw into this void here. Over on this side, same deal, but this one's oriented so that the pry void is back on the back side here where you can't see it very easily. But again, it should come pretty easy. Just with gentle encouragement. With some basic level of mechanical sympathy, you really aren't going to screw anything up too bad on one of these. The trick now is getting the shaft to line up with these bores, because you do have the eccentric ends here. Once you get it, she'll pull right out. Make sure you're hanging on to the back gears so they don't fall. So I misspoke / misremembered when I referred to the bushings earlier as being eccentric, because they're not. It's the shaft here that is. This little pin here that's a bit bent on mine, that engages with the bushing here. And that's what gives you the limitation of the range of movement. Looks like this has been abused a little bit. Alright, we're perilously close to removing the spindle here. We're going to take you down to the cone pulley. Alright, light's not the best back in there, but I got a little handheld light we can use. This is the pin here for engaging, disengaging the direct drive. So we're going to pull that out to separate the spindle drive from the cone pulley. And we're going to take out this retaining screw right here. keep track of these screws because you probably won't find any two that are interchangeable. So do you see this chewed up spot on this slot here? If you've never taken one of these apart, that's probably going to be your clue that something needs to be going on here. If you look real close, I don't think you'll be able to tell from your angle. You can see just the start of some threads back here. This ring here is threaded and retains this drive arrangement. That screw we just took out keeps this ring in place. So what we need to do is find a way to engage with that slot and remove the threaded ring. Note also the broken gear tooth near that slot. So be careful. It shouldn't take much to get it moving, especially if you've had it apart before. This is too big a tool to have in there and be safe with the gear teeth. This is also a lot harder to do while holding a light. Let me bring you around to a slightly different angle to show you what's going on. So we've got this collar that we just unthreaded, and it bears against this edge of the gear. There's a little bit of space here that will allow the gear to slide off of its mating surface of the spindle here. Now, rather than pry on the gear, the best way to handle this is to gently tap the spindle from the rear to separate this gear from the spindle itself. So you definitely don't want to pound the snot out of it, but just some gentle tapping and you should start to see the spindle work its way forward. Once you've got it driven in all the way, it should pull out by hand. So we want to put your hand under the cone pulley arrangement to support it, and then just gently pull the spindle forward. Have a convenient place ready to set your spindle, because you're not going to want to walk away with the cone pulley just hanging out here unsupported. Inside the back of the cone pulley here, you've got the tumble reverse arrangement that'll be keeping the whole pulley assembly from falling directly out. So you have to kind of tip it and remove it, but that spindle drive gear is still hanging out in there loose. So you want to fish it out first. Carefully remove the pulley. Let's take a closer look at the bearings here. Right, the front bearing race has a double taper. This front one acting as the thrust bearing. A little hazy in there. Definitely marks. Nothing you can catch your fingernail on, that's for sure. No bad scoring for 100 and something years old. I think they're looking pretty good. They feel and look smooth all the way around. You can definitely see the wear patterns inside. Sometimes with plain bearings like this, you can turn the bearing seat periodically to help even out the wear from gravity or the tension of the belt. You shouldn't leave the belt tension when you're not using the machine anyways, but these have oil passageway cut specifically to match the oil cup location up here. So if you start moving these around, then you run into problems with the oil, I think. Let's take a look at the rear. So the rear bearing race here is perforated, as you can see. It's also looking pretty good. No surprise. This would be a good time to disassemble your tumbler reverse mechanism. And basically this whole thing is pinned in place. So each of these tumbler gears in here, twist it around until you find the hole between the teeth, and that's where it's pinned through. And same thing on this end. This collar here is pinned to the shaft. You can see the end of the pin there and there. This is the big end, so you drive it out from this side. I'm going to do a little cleanup in here, but I'm not going to disassemble this whole thing because it really is a pain in the neck. Alright, I changed my mind. I'm going to pull out the tumbler assembly, clean it up, and I'm going to make a replacement spindle gear. I can't bring myself to reinstall this gear with a broken tooth yet again. So hold on just one moment, I'll be right back. First thing when removing the tumbler assembly is to get the change gears and this sector banjo, whatever you're calling it, out of the way, because the little detent arm here for operating the tumbler reverse can't come off all the way with all this business going on here. If you let the sector hang down like this, there's plenty of room for everything to come off. There's a pin holding this collar in place. You should be able to tell just by looking which way the taper goes. There should be a large end, the head, and then a smaller end here. Collar slides off, and this whole shaft and gear pulls out from the inboard side, and this whole collar, as well as the lever, will slide off. It's keyed. With that removed, the remaining assembly should come out from the inboard side. It may require a bit of encouragement. There we are. I think that'll do. The spindle thrust in this direction towards the tailstock is taken up on this surface here. The mating bearing surface is on the front of that pulley assembly. Let's go over to the bench and take a closer look at the bearing surfaces on the spindle itself. and that pulley assembly. We can get a closer look at the spindle here. Bearing surfaces are in pretty nice shape, especially given the age. There's some visible scoring, nothing you can feel at all. It's all perfectly smooth. This spot right here is where the collet pin is driven in. If you look through the spindle there, you'd see the pin or the key that engages with the keyway on the collets. At the front of the pulley assembly here is our thrust bearing, also in real nice shape. Be careful not to lose this and drop it when you're working with the pulley assembly. The suction from the film of oil can keep it held in place well enough that you might not realize that it's a separate part until it drops and hits the floor and shatters. The pulley halves will separate. Big old bronze bearings inside the cone pulley here. Everything's been pretty well cleaned up and oiled, so let's put her all back together. Alright, it's late and I'm tired, but we're gonna show you what we ended up with here. I don't think you can quite see it from that angle, but the position where the key is, right about here, the teeth are just a little bit tighter in that spot on the rotation. I think a little bit of extra pressure from the key fitting moved things just a little bit. So with the tumbler in this position, which is where I would typically have it for power crossfeed moving toward the center of the work, it's pretty quiet. It meshes nice. With the tumbler in the other position, and this is the position that I would typically use for power longitudinal feed, that spot where it's a little bit tight, you can kind of hear it. That's what it sounds like under power. Not terrible, but a little bit annoying. I got in there a little bit already with some Riffler files. I don't know if you can tell this on video. You can see some of the spots on the teeth where I've worried away at the high spots a little bit. I'll continue with that, and I think we'll get it into pretty good shape. But for now, we're going to try a couple of test cuts just to make sure everything is okay. Alright, we'll start with a facing cut using the power crossfeed. A little bit of Canadian cutting oil here. Alright, I misspoke. The tumbler position with the quieter gear meshing is what I typically use for the power longitudinal feed, not the cross feed. Let's take a real cut. Get her in back gear. Yeah, it dished a little bit. Something moved. That was a awful heavy cut for this compound arrangement here. Let's try another cut. Alright, we're going to zero against the larger diameter here. Come in 100,000th depth of cut from that. I'm going to choke up on the tool a whole bunch here. Sticking out about 2.5 inches. Alright, coming in with 100,000th depth of cut here. Let's take something a little closer to a finishing cut here. Try a little bit of a facing cut. tool height's a little off there. Well, I think we're pretty good. Got to do something about that noisy gear in this tumbler position though. Well, thanks for watching, and I hope you found this weird old machine at least a little bit interesting. We'll see you next time.